Planetary Science is like the best mystery novel that spans for years with hundreds of detectives. So scientists are able to take these tiny clues, little pieces of data, and put together these big explanations and stories that help us understand worlds, bodies that are very, very far from us. Now, there's a lot of challenges to this. And one of the big mysteries is trying to figure out what is happening inside of a planet when you can't literally go inside of a planet. So, here on Earth, we're actually on Earth. So, we have this great advantage that we can use seismology to help us try to figure out what's going on inside of the planet. We can essentially listen to earthquakes. We have a lot of data to work with. And we can do that with the moon and Mars, places that we can land on. But what about worlds that we can't land on? Or at least for the time being, are without outside of our reach. So let's say, for instance, Jupiter. How do we figure out what's happening inside of Jupiter? You can't land there. We can't send probes very deep into the planet. We have sent one, but that didn't make it very far before being destroyed. Or what about also in the Jovian, the Jupiter system, Europa, one of the icy moons there that we think is covered in a thick layer of ice with an ocean, a very thick ocean underneath. And at the base of that, we think probably a rocky floor. How do we figure out what's going on there without being able to yet land there, drill through that ice, go down through all the oceans and look around? So, scientists have to come up with really clever and creative tools to help them find the clues and start to piece together the stories. And one of the amazing things is that sometimes we find a clue and think that that piece of the puzzle fits in one spot. But later, as we get more pieces of the puzzle, more clues, we find that, that's maybe not the case. And we're going to need to arrange things in a different way. So, one of the amazing tools, which is being used right now and discussed for being used in the future, is the tool of gravity itself. So we have two really amazing recent studies that have come out, and both were published in the Planetary Science Journal. This is an open access journal, which means you don't have to pay to get access to it. And I'm going to put the links to the actual studies so you can check it out. But I'm going to go ahead and read the titles too so I get it exactly right. So the first one is Juno spacecraft measurements of Jupiter's gravity imply a dilute core. So really interesting here. And Burkhard Milzer is the lead author on this with a whole team of other fantastic scientists. And our next one is assessing the detectability of Europa's seafloor topography from Europa Clipper's gravity data. And this is Ziwin Ko et al. Right? So et al is just everyone else, because usually you're going to notice with papers like this, right, you're going to have a lot of authors. So the lead author is who's going to be mentioned, but there's all of these other people who contribute to it as well. But let's actually dig into this, because these are doing something really, really interesting. And actually, both from the Jovian system, both of these papers were published within several months of each other in 2022, but different teams. So with our Juno paper, Juno is a spacecraft at Jupiter, right? So Jupiter has been visited by many different craft, starting with flybys like the Pioneers and Voyager. Then we also had, who else do we have? So Ulysses, Cassini, New Horizons, Galileo, which is an orbiter, and Juno. Juno, by the way, is Hera, right? So I think that's fun. But we've had many craft at Jupiter studying it. Now, what Juno is doing is studying the whole system, but it's been able to gather gravity data, right? So looking at the gravity field. Now, looking in, you're going to see storms around the outside of Jupiter, right? But the gravity, that can actually start to tell us, that field, about what might be going on inside of the planet. Now, the story that I learned, right, thinking back to when I was learning about the planets, I remember seeing a chart that had, or a picture, a diagram of Jupiter. And at the very center, there was this dense ball, this really dense core of all the heavy stuff. So Jupiter is going to be made up of not just hydrogen and helium, but it also has iron and nickel and uranium and all of that stuff that would have been present in the nebula that ended up collapsing to make our star, and so on. So the standard pictures that you see in textbooks have this really compact core, and then these nice, neat layers of our metallic hydrogen, our liquid hydrogen, and then our gaseous hydrogen, right? Now, what this team was doing was looking at the actual gravity field based on Juno data and going, okay, well, what models for the interior of this planet best match the actual observed data, right? Now, these models, some of the authors were involved with making these models, some of them came from other teams, but trying to figure out what's going on, how far out does the core go, what's the density of the core, all of those sorts of things. And what they were finding was that their data best matched a model in which the core was actually dilute, right? And that this diffuse core stretching out to about 63% in the planet. Now, that is very, very different than the pictures that we're used to seeing in the textbooks. So they're able to build on these pieces of the puzzle that we were talking about earlier, right? Putting these puzzle pieces together and seeing that, maybe we need to start rearranging these a little bit. Now, in planetary science and any science, the matter's never really solved and done. There's going to be a lot more information that can be gathered. Maybe there can be new measurements taken, right? Maybe there will be other ways that we can figure out to start to try and figure out what's going on inside of this planet. Now, if we switch over to our other study, which is our Europa study. So this one isn't using real data yet. So the Europa Clipper is hopefully a mission that will be sent to Europa to actually study Europa specifically. So other missions that have visited Jupiter have also visited Europa and have taken some measurements, taken photos, all of those sorts of things. But they haven't been to specifically study Europa. And that's what the Europa Clipper is going to do. Now, we think that Europa is a world with an ice shell. Certainly we can see the ice shell. And then based on a lot of different lines of evidence, we think that there's probably an internal water ocean world. So this huge ocean, probably with more water in it than all of Earth's oceans. By the way, Europa is a body roughly the size of the moon. So that's a huge ocean, right? And underneath, we think that there is a planet that is somewhat similar, you could say, to one of the terrestrial planets. The density is a little bit different, but kind of in line there. So there should be a floor to this ocean, right? And then underneath, we're going to have the denser core at the center. But the floor of the ocean, well, what's that like? What's the topography like? Are there mountains? Are we going to find huge volcanoes? What is there? So what this team was doing was looking at, okay, could we use gravity readings? Sort of like, now they weren't comparing it to the Juno study we were just talking, to the study looking at Juno data we were just talking about. But basically with the same general principle, could we use that to actually figure out what the topography is of the floor of Europa's oceans, of the European oceans? So we'd be looking through, not visually looking, but reading essentially the tug of gravity. The more stuff you have in one area, the greater that density is, the greater the gravity tug is going to be, right? So could we use that to figure out what the floor was like? And they looked at several different potential models for what the floor might be. One of them really interesting is there might be a thick layer of gypsum. And how would these models be influenced? Or rather, how would the data be influenced? How could we see that if that was the case? So this is really looking at the feasibility. How likely would it be that we could use this tool to figure out what's going on inside of Europa? A totally different planet type than its primary planet, Jupiter, right? So these are the types of things that we are exploring and looking for in planetary science. Now, in the future, we're going to talk about all kinds of other techniques that can be used. But I think it's really interesting, and I specifically chose Jupiter and Europa to start this off with, because the discovery of Europa and the other Galilean moons, so those four big moons around Jupiter, in some ways really is the beginning of planetary science itself. So we call them the Galilean moons because Galileo spotted them through his telescope. And when he did, this is when the realization happened that, wow, there are other planets out there, right? Up until that point, we knew of the objects that we could see with the naked eye. But this is when we really started to understand that that Earth was like them, and there could be other places kind of Earth-like, other planets. Now, planetary science didn't really come into its own until the 1960s when we started being able to send missions like the Pioneers, Voyagers, or New Horizons, Juno, all of these objects, being able to send these craft out. And now, in the 21st century, we're starting to be able to do a lot more with these creative tools like using gravity, right? Using all of these different kinds of telescopes and creative methods to study these worlds. So there's some really amazing and interesting stuff coming up.